In the huge universe, NASA has found almost 5,300 exoplanets in the past 30 years. These are distant worlds that we can't reach, but they hold many secrets waiting to be discovered. Out of all the exoplanets we've found, only 59 of them might have the conditions for life. Could there be alien life on these distant worlds? Maybe they're even looking for us, just like we're looking for them. In fact, there are 3 planetary systems, each with at least one habitable planet. People have always wanted to explore other planets beyond our own. Now, thanks to advanced technology like the James Webb Telescope, we can finally start making those dreams come true. In our Milky Way galaxy, we can find numerous compact systems that revolve around stars, much like our own Sun. However, not all of these systems are suitable for supporting life as we know it. The distance between a planet and its star plays a critical role in determining its habitability. Planets that orbit very close to their stars tend to be too hot, making them unfavorable for hosting life. But here's where things get interesting. When it comes to colder and fainter stars, the habitable zone, the region where conditions are just right for life, is actually much closer. And that brings us to Gliese 667, also known as GJ667, a remarkable triple star system situated in the constellation of Scorpius, a mere 23 light-years away from our Earth. What makes Gliese 667 special is that it contains the first known instance of a system where a low-mass star is accompanied by multiple potentially habitable rocky planets orbiting within its Goldilocks zone. This zone, often referred to as the just right zone, provides the right conditions for life to flourish. Just like the Alpha Centauri system, the Gliese 667 system also consists of 3 stars. However, not all the planets in this system are equally suitable for life. Let's start with GJ667a, the largest star in the system. It's a K-type main sequence star resembling an orange-red dwarf. Compared to our Sun, it has a mass of 73%, a radius of 76%, and only emits about 12% of the visual luminosity. GJ667b, its companion, is also an orange-red dwarf of the same K-type. It has a mass of about 69% of our Sun and radiates only 5% of our star's visual luminosity. However, these 2 stars aren't the best candidates for supporting life. They have lower temperatures and energy output, which means their habitable zones are limited, making it tougher for planets to survive there. People near these stars may face intense radiation and extreme temperature changes, resulting in inhospitable conditions. But here comes the interesting part. Gliese 667c. It gives us more hope. Gliese 667c is an M-type red dwarf, much smaller than our Sun, with a mass and radius only 1/3 of that of the Sun. It's remarkably faint, emitting only 1.4% of our Sun's luminosity. The surface temperature of this comparatively cold star is around 3,775 Kelvin. Despite its small size, GJ667c hosts a surprisingly rich planetary system. Initially, scientists believed that there were only 3 exoplanets orbiting Gliese 667c. After taking a closer look at the data and making more observations, scientists found something exciting. There might actually be 6 planets in the Gliese 667 system. And guess what? 3 or maybe even 4 of them could be super-Earths that have the potential to support life. Now, you might be wondering what exactly is a super-Earth. Well, it's a planet that's bigger than our Earth, but not as gigantic as gas giants such as Jupiter and Saturn. These super-Earths can be made up of rock or a mix of rock and ice, and some of them might even have atmospheres that could provide a suitable environment for different forms of life. The planet closest to the star, Gliese 667cb, is an incredibly hot place with temperatures reaching a scorching 2,000 degrees centigrade, 392 degrees Fahrenheit. It's also the largest planet in the system, about 5.5 times the size of Earth. Due to its proximity to the star, it experiences intense radiation and extreme temperatures. In fact, it completes an orbit around its star in just 7 days. Gliese 667CE, on the other hand, is located further away from star C compared to CB. This exoplanet is about 2.7 times the size of Earth. Unfortunately, it falls outside the habitable zone of the star, where conditions for having liquid water become less favorable. As a result, the chances of supporting life on Gliese 667CE are significantly reduced. Moving away from the star, Gliese 667CF finds itself in the outer edges of the habitable zone. This means it falls within a range where conditions for life could be more feasible. It offers a climate that's more moderate compared to its neighboring planets. However, to determine if Gliese 667CF truly has what it takes to support life, more investigation and exploration are needed. Scientists will need to delve deeper into its atmosphere, surface conditions, and other factors to understand if this distant planet could be a potential abode for living organisms. Gliese 667CG, on the other hand, exists outside the habitable zone of star C, which means it's not in the ideal range to support the conditions necessary for liquid water to exist. The temperatures there are extremely cold, and any water present would likely freeze, transforming the planet into a massive icy landscape akin to Antarctica. Unfortunately, these harsh conditions make it highly unlikely for life as we know it to thrive on Gliese 667CG. Without the essential element of liquid water, which is crucial for the development and sustenance of life on Earth, the chances of finding living organisms in such an environment diminish significantly. However, among the planets orbiting Gliese 667c, there's one that catches our attention as a promising candidate worth exploring further. Gliese 667cc, the planet closest to its star, resides within the inner edge of the star's habitable zone. It has a mass approximately 3.8 times that of Earth and a radius 1.8 times larger, completing its orbit in just 28 Earth days. With an Earth Similarity Index of 0.85, Gliese 667cc is often referred to as the Holy Grail of extrasolar planets. Due to the low energy output of the red dwarf star GJ667c, its habitable zone is located very close to the star, ranging from 0.11 AU to 0.23 AU, entirely within the orbit of Mercury. In comparison, Earth is situated at about 1 AU from the Sun. If our planet orbited star C at that distance, it would become an icy world. GJ667cc orbits its parent star at a proximity of approximately 0.12 AU, which is 8 times closer than Earth's orbit. This results in the likelihood of the exoplanet being tidally locked, with one side experiencing eternal day and the other eternal night. Gliese 667cc receives around 10% less light than Earth does from the Sun. However, since most of the light it receives is in the infrared spectrum, the planet still obtains a similar amount of energy as Earth, which would aid in the retention of water on its surface and contribute to a climate resembling that of our planet. Due to uncertainties regarding the thickness of Gliese 667cc's atmosphere, it's challenging to predict its exact surface temperature. If the planet possesses an Earth-like atmosphere, heat transfer would occur, equalizing temperatures across the entire planet and resulting in a pleasant 30 degrees centigrade, 86 degrees Fahrenheit on the night side. The other two stars in the system, Gliese 667a and b, are situated much further away from Gliese 667cc at a distance of approximately 230 AU. However, on planet 667cc, these two stars would still appear as a pair of bright stars visible during the day, and at night they would shine as brightly as the full moon. Our Sun, on the other hand, would appear as a distant star. Living on Gliese 667cc would be a completely different experience compared to what we're used to, mainly due to its significant mass. The planet's higher mass would result in a different gravitational acceleration on its surface. As a rocky world, the gravitational pull would be up to 60% stronger than what we experience on Earth. For example, a person weighing 80 kilograms, 176 pounds on Earth, would weigh as much as 128 kilograms, 282 pounds on Gliese 667 cc. Let's take a closer look at the fascinating star system called TOI 700, which is located about 101.5 light-years away from us. At the heart of this system lies TOI 700, a small and cool M-type dwarf star, unlike our Sun. First, we have TOI 700b, the innermost known planet in this system. It orbits very close to its star, completing a full revolution in just 9.98 Earth days. Due to its proximity, TOI 700b experiences extreme temperatures, making its surface almost boiling hot and inhospitable for any potential exploration. Using data from NASA's Transiting Exoplanet Survey satellite, in the TOI 700 system, scientists have found an Earth-sized world known as TOI 700e. TOI 700e completes an orbit around its star in 28 days. The distant planet resides within the habitable zone of its star, the perfect distance where liquid water could exist on its surface. With a size 95% that of Earth, TOI 700e is likely composed of rock. It took an additional year of observations from TESS to unveil the existence of TOI 700e. The detection of TOI 700e was challenging due to its faint signal, but thankfully the astronomers were able to identify and study it. In the vastness of space, there is another planetary system called Wolf 1069, but unlike system TOI 700, this system consists of a single star. It's located about 31.2 light-years away in the constellation of Cygnus. This star, known as a red dwarf, has some fascinating characteristics. It's much smaller than our Sun, with only 17% of its mass and 18% of its radius. Wolf 1069 has a temperature of 3,158 K, 2,885 degrees centigrade, 5,225 degrees Fahrenheit, and rotates slowly, taking about 150 to 170 days to complete one full rotation. Within the orbit of Wolf 1069, there is a solitary companion, a single exoplanet. Wolf 1069b, a rocky exoplanet, orbits star Wolf 1069. It's located a mere 31 light-years away from Earth, making it relatively close in cosmic terms. This newfound planet holds great promise as a potentially Earth-like world. It has a mass 1.26 times that of Earth and a size 1.08 times that of our home planet. Wolf 1069b zips around its star in a mere 15.6 days. What's particularly exciting is that Wolf 1069b resides within the habitable zone of its star, the region where conditions may be suitable for liquid water to exist on its surface. The remarkable discovery of Wolf 1069b was made possible with the help of the Carmenes instrument located at the Cala Alto Observatory in Spain. By using the radial velocity method, which detects subtle variations in a star's location caused by a planet's gravitational pull, astronomers were able to confirm the existence of this intriguing exoplanet. If you could visit one exoplanet, which one would you choose as the future of humanity? Stay tuned for more videos and comment what topic do you want us to cover next.